All right, so this is approximately where we left off with yesterday. So within this class, or not this class, within this phylum, how many classes have we discussed so far? Close. Actually, three. Okay, and we're referring to the jawless fish, which are there's two examples. That's the class, but what are the actual names of the fish? You might not have wrote it down. One starts with an L, the other one starts with an H. No? Okay. So one's a hagfish, the other one's a lamprey. And yes, those are in the class Maxini. And what's significant about them? Hopefully you can think of two or three things. What would that be? Why are they in that class? Because they lack something. Not a backbone. They still have that because they're still vertebrates. Yes, they lack a jaw. And what about flotation? How do they accomplish that? They don't have a large liver like sharks. They don't have a swim bladder like bony fish. So it's something else. It's a type of movement of water. And from biology class, what's that called? Yeah, so it's an osmotic equilibrium that does that. Then we move on to the sharks, which have again, that large liver that helps in its buoyancy. Remember, all fish are heavier than water. And then finally, you get to the osteocheiths, which are the bony fish. And this is where we left off with yesterday. And moving through water is, again, we said pretty tough. And even talking about those sharks, for one to be moving, especially that large, that mako moving 20, 30 knots, which is pretty close to probably 34 miles an hour. Those aren't the fastest fish. We saw that yesterday. And an example of that was it yellowfin or bluefin? I think it was bluefin or faster. Was it bluefin? And according to that narrator said moving up to, was it 60 knots? Was I imagining things when I heard that or no? Just say, you're getting old, you're just imagining things. Well, we didn't want to say anything, but now you mention it. Yes? No? Yeah, we'll go with that. So we'll say 40 to 60 knots, which is probably close to 50 miles an hour. Now, I find it hard to believe that a fish could shoot straight through the water like this, moving that fast. Rather, if it's going to have that type of speed, it's more so maybe doing what instead? Going down. That's right. And with this zigzag pattern, the way these bands work, okay, these muscles are called myomeres, and that is one of your vocab terms that we'll get to next week. But there again, this is a type of wave motion. It's very efficient from left to right. And did we talk about this yesterday? Is this where we left off with? Okay. So then we move forward. That's right. Oh, yes. Oh, oh awesome. Oh. All right, so when we're talking about this locomotion in water, okay, it's talking about this highly resistant medium. Now, a medium can be anything from air to water to dirt to mud. Any one of those is considered a medium. Okay, so in this case, why would this be the case? Not very efficient means for small fish. Okay, why would we say that? I mean, that tail can be moving side to side, and swiping, but is it going to move very far? Of course, the answer is no. And it's not because the fish is slow. It just doesn't have, it has the power, but it can only drive its tail so far. Because remember, for the majority, and that was very evident in the tuna that we saw yesterday, their tail was considered as what type as opposed to the majority of sharks. The difference in their tail is what? If we remember. One term would be homocecal, the other one would be heterocecal. But what's the difference between those two tails? Pick one. Okay, so does that mean that the tail fins that are going down that vertebral column, are they the same size on the top and the bottom? No, they are not. It would be perhaps something like this. The majority of sharks have something like that, to where we're trying to illustrate the thumbs are actually sticking out larger on top than what they are on the bottom. That's your heterocecal tail. How's that different than homocecal then? What about both sides? Yeah, they would be the exact same size. And that was very evident in them blue tuna. And the larger that animal, okay, the more surface area that has to push off. And that's what they're talking about here. The larger the fish, the faster it can swim. And that would make sense. And I had no idea tuna got that large. I was under the impression that 800 pounds was about as large as you're going to get for a tuna. Is that the case what we saw yesterday? No. 1,600 pounds? I mean, that just boggles the mind. Now, with that, what did they illustrate in there that shows why these animals are so fast? Besides their tail, besides their muscles. What about their structure? You're right. Well, I suppose it's designed for that, but what is it that makes it so perfect, like you're alluding to? That has something to do with it too, being warm-blooded. But, yeah, it was more pointed in the snout like that of the sharks, in that water just streamlines around it, very much so. In my opinion, just by design of some of these semi-trucks, okay, what are your major, I don't want to say brands, but models? Of course, I know you got what, Peterbilt, Kenworth, International, and isn't there one that's named after a dog or has that for a mascot? Is that Mack? Okay, and then so that's up to 6 so far. So what I'm thinking of, I think the South Dakota National Guard for the Transportation Unit, I think their contract goes out to Freightliner. Okay? It's, when you're going down the road, it's unmistakable. You know you see a Peterbilt when you see them. It's, they just stick out for probably 2 reasons. One, what's the first thing that, it's what I notice in a semi, I always think just looks so cool in the design. This, which is what? Right. They're not smokestacks, but exhaust pipes. You have the dual types. Now, what else is significant about these Peterbilts. Yeah, they look like a box. It doesn't look like they'd be very efficient going down the road. On the other hand, maybe that's why the military or the government decided to go with Freightliner. How do they look different than a Peterbilt? Yeah, it actually has. I suppose that's the way to look at it, is round, but it has more curves on it than that of. But Peterbilt, I think, has changed their designs in their newer models. Does that sound right? Okay. So if that's the case, I think if you're just doing local trucking and you like just the Peterbilt name, you're probably going to be more of a traditionalist. Would you agree? But if you're an over the road trucker, if you're going to Denver or Cheyenne or Phoenix or something to that effect, you might not stick with it. You probably might go with a newer model or one that's more curved shaped. I don't know if there's much difference in the fuel consumption. I don't know. That's why I'm asking. Okay. So, but with that, some of these, if they're more curved shaped, they're going to be more aerodynamic to move through the water, like you had alluded to. And the larger area to actually push off with these tails and more muscles, the faster it's going to swim. I mean, and that would totally make sense. Okay. So these myomeres is what we're talking about. Think of an M on its side. I think maybe it says that somewhere, but that's what a myomere actually looks like. It's a zigzag band of muscle. So when you look at it, the way that these muscles contract, it's different than that of mammals, reptiles, humans, birds, because again, just picture an M on its side, and that's how it actually contracts. And I think where we left off with, it's showing some of those tuna fillets being cut in half. And you'll be able to see those zigzag patterns, I'm thinking, especially in the sharks, when we cut those open tomorrow. You'll be able to see those zigzag patterns. I'm going to do one more after this. See, are we breaking our face? Are we putting any strain on it? Okay. I'm just being mean, though. That's my problem. Yep. So next time you buy these, on its side and produces that more powerful movement. So, again, next week we'll probably have a vocab quiz at some point. We'll have papers to hand out on Thursday, which we see would be a week from this Thursday's approximately when they'll be due. So I think we're just a little bit over halfway through this content, and some big concepts to keep in mind is I want to say jaw structures. Their buoyancy is affected by their liver, and then finally the bony fish, they actually have a swim bladder that will regulate the amount of air coming in and out to affect their buoyancy. All right, so we next Monday you have off. So out of the next, we see one, two, three, eight. Out of the next 9 days, you're only here for 8 because we have Monday off. Well, some of you do. I think you have a game that night. Is that when Dakota Valley Conference starts? Does that sound right? Okay. So then won't be long. We'll get out of the month of January, and to me, and I think you would agree, that's probably when you picture the school year really starts to pick up in speed, and maybe it's even at that point you think, oh, it's only February, or oh my gosh, it's February already. People, I don't know which way, one way or the other, but again, we'll catch up to you next time.